Hello everyone, dear guest, dear colleague. My name is Filip Tsatanov. I'm from Southwest University in Blagoevgrad, Bulgaria, and I'm going to present a paper with topic storing data from sensor networks. Objective of the paper, analyzing the problem of storing large volume of sensor data when integrated them into a cloud structure, research and systematization of sensor data and cloud databases suitable for storage of sensor data, development of a proposal and recommendation for selection of appropriate databases for storage and proceeding of sensor data. The main headlines of the presentation are a brief introduction to the problem, integration of the sensor data in the cloud, including block diagram of the integration, analysis of the methods for transmitting data, communication between the sensor network and the cloud, and also databases for storing and managing data from sensor networks, basic models of the storage and proceeding of the sensory data, time series databases, and consideration for choosing the best database. The amount of the data generated by the sensor networks is huge, heterogeneous, and multidimensional. Significant hardware resources of the sensor nodes are required for the storage and proceeding of this data. Integration between the clouds and the sensor network is an excellent solution to the problem of the limited computing power of the sensor, increasing not only the life of the sensor network, but the storing and proceeding the whole collected data from the sensors. Storage of the data is performed more frequently in various databases, which may be the integrating into the cloud structures. We are often faced with the dilemma of what a database is suitable for storage of the sensor data. On the slide is showing block diagram of the integration, and usually what's happening, the data collected and recorded by the individual sensors is transferred to the cloud, proceeded, and can be viewed, manipulated, and modified via client devices. And the cloud themselves is usually with a different structure, depends on the project needs. There is two ways the data to be transmitted. The one is by the coordinator, and the second one is directly. First, the data is transmitted to a coordinator, provides options such as calculation of average or a peak measurements data values, the transmission of only data that has extent to the configuration threshold, compression, or other data encoding, transmission of the raw data or pre-processed data. The second type is directly, when activated the sensor via RF modules to read the measurement result and send it directly. In that case, the coordinator may miss or gateway to perform other role. On the slide is showing the block diagram of the method of communication between the sensor network and the cloud. The block diagram is very similar. The diagram is activating the sensor. The sensor is generated that data and is transmitted directly to the coordinator in that situation, and the coordinator can proceed and transfer raw data to a different databases in the cloud. Characteristic of the sensor data. Sensor data from a single sensor are simple time series. Often, for an extended period, the data from the sensor may not change its value. There is a case where a volume of the data grows rapidly, several reports per second for one or more sensors from one network. The basic models, they are divided by three. And the first one is storage and proceeding the data outside the network, the sensor network. The second is distributed storage and proceeding on the network, and combined solution. In the first model, storage and proceeding the data outside the network, is a continuous stream that accumulates without loss in the network, and then the data is transmitted and archived outside the sensor network. The collected data can be stored in a different storages and can be made a request to access that data using standard methods. This method is implemented by a large number of already implemented networks designed to monitor all phenomena. Such a network are easy to implement but can be short-lived, especially when using high-speed sensors such as cameras, acoustic or vibration sensor, and etc., as the data transmitted require often draining the whole available energy resources of the devices and the network. The second, distributed storage and proceedings on the network. For working with the sensor uh, data, considers the sensor network as a distributed database that supports requirements of the data provision and proceedings. In this model, the request is directly to the sensor network, possibly to remote sensor node that store their data locally. This architecture is potentially more energy efficient because the request is proceeded on a smart sensor node, and the results of the request is transmitted as a proceeded data rather than raw data. The energy cost of the transmission of the large amount of data exceeds the cost of their local proceedings. Time series database are specially designed to store sensor data. They belong to a group of not rational databases because they use search languages different but very similar to SQL. NoSQL is mostly used in real-time web and big data applications. A time series database is a software system that is optimized for handling time series data, areas of the number indexed by the time. The timestamp usually has um, an accuracy of a seconds and milliseconds, but with the removed data collection and accuracy can reach to nanoseconds. The timestamp supports automatic adjustments of the time zones. The frequency of data reporting can be periodic or when the event occurs. Time series database is optimized to manage change over the time. On the slide is a showing the types of time series database. According to the type of the license, the database can be classified as open source, commercial, academic databases, and industrial databases. The figure shows the applicability, the various databases for September 2020. There is many companies that make analysis for the applicability of these databases. On the slide is showing that the first in the list is influx databases, and is the most applicable for this year and actually for a couple of months and years back. The choice of a specific database may depend on the specific of the implementation of the application that can use that sensor data which is going to be collected. What is influx database? Influx database is a special created open source time series database. Influx database is available in two versions, Influx Enterprises and Influx Cloud. The Influx database model has a linear protocol for sending data from a time series which can take the following from the measurement name, the tag set, field with the set, time set, and etc. Usually, there is using the float 64. Most often solution for time series is only support float 64 values, which mean that the users is enabled to encode additional metadata along with the timelines. Due to all these factors on the slide, Influx database is the best solution for working with the time series data lines. Conclusion. analysis for the integration of the sensor data in the cloud structure is made, allows solving essential issues about the cost of the sensor network and the possibilities for storage and analyze the sensor data in specialized databases. Analysis made for the modern solution for storage and processing of sensor data, identifying the models of the storage of the sensor data and the approaches and possibilities for their application. Also, the GNOME time series database is specially designed for storing data from sensors are systemized. One of the most preferred database, Influx database, provides plugin capabilities, multi-cloud supports, data analysis solution, query builder, powerful client libraries, and 24-hour supports for open source users. Influx database processes data quickly on order of milliseconds, nanoseconds, and making the database preferred for a financial and scientific purposes. Thank you very much. And if you have any question, I with love, I will answer it on my email address. Bye for now.